Good morning everybody. Today I am going to do the seminar based on the topic of circular queue. So I'll start the seminar by asking two questions. The first question is, have you guys ever used Free Fire and Instagram? I know most of you guys have used it. So have you guys ever wondered that when the players get eliminated, how they will be queued back to the second round, or else whenever you are using the Instagram, when you click on the right side of the story, it will go to the next story, and when you tap on the left side, it will go to the previous one. So this whole scenario works based on the circular queue. So let's see what is circular queue actually means. So this is also works as the same as linear queue. It is also the linear data structure, and but the difference is in this circular queue, the last pointer will be connected to the first element, and it will be represented in the form of circular manner. So this is the representation of circular queue, and this is the representation of the linear queue. And the difference between linear queue and the circular queue is, first one is structure. In the linear queue, we store the elements in the linear manner, and in the circular queue, we store the elements in the circular manner. And there is no linkage between the first and the last element of the linear queue. And in the circular queue, there will be a connection between front and the rear pointer. That means last element and the first element. And there is no there will be memory usage in the circular queue, as when you delete or when you perform the DQ operation in the circular queue, that place will wrap around to the next element, so that it will form the circle, where the memory usage will be higher compared to the linear queue. And there will be a formula for circular queue also. So let's see the formula. The formula is rear plus 1 modular of size equals to front. This is used to check whether the queue is full or not. So NQ is the operation performed on the circular queue to insert an element at the front pointer. Next. And DQ operation means this operation done in the circular queue to delete an element from the rear pointer. So advantages and disadvantages. Advantages of circular queue are, first one, as I mentioned earlier, first one is memory usage. How the memory is used in the circular queue means, when you delete an element in the circular queue to form a circular manner, that element, if you delete 6 elements from the circular queue, this edge and this edge will wrap around to form a circle again. Through this, the memory usage will be done. And the second advantage is wrap around. As I said, automatically goes from end to start forming a circle. Faster performance. So there will be no shifting of elements in the circular queue, and it will be of the fixed size and especially used for the embedded system. Disadvantages of the circular queue are, as it is a fixed size, you can't add or insert an element dynamically, and there will be a complex implementation compared to the linear queue, because you need to care about the rear pointer and the front pointer. And difficult debugging. Errors like overflow, underflow occurs more compared to the linear queue. And it's not beginner friendly, as you are learning DSC, you should first look into the linear queue, and it is more complex than the linear queue. So real world application of the circular queue are data buffering and operating system. Particularly in the operating system, it is used for the round robin technique. In the round robin technique, we will use a concept called quantum. So you need to add the processes to the CPU based on the given quantum time. These all processes will be waiting in the circular queue. You should use mostly there. And the data buffering for the streaming audio and video data packets, it will be used. Next slide. Yeah. So as it is a building block of the DSA, it's a foundation to understand more depth in the DSA, and it will be used in the operating system as well as the system level program.